This lesson is Unit 2, Section 1. It's from the textbook, Section 1.3. We're going to be talking about piecewise functions. Piecewise functions are functions defined by two or more equations. Each piece of the function applies to a different part of the domain or the x values. So this is an example of a piecewise function. They're showing us that x minus 2 is the line. For the domain, x is less than or equal to 0. So we notice we start as x is 0, and then everything to the left of it is the line x minus 2. Then if x is greater than 0, the line is 2x plus 1. So starting at 0, going to the right, is the line 2x plus 1. Notice we have an open circle on the second line because it was not equal to x at that point. X is greater than 0, not greater than or equal to. All right? Whereas this one had equal to 0, so there was a solid dot. So we're going to find the value of the function based on the graph. So the first thing I want to find is f of 2. So I'm going to look where the x value is 2. So on my graph, I go 1, 2, and I find where the graph has crosses the line. So the y value when x is 2 is positive 3. Now I'll look at f of negative 1. So I go over to negative 1, find my graph, and I want the y value when x is negative 1, and that is positive 2. The last one I'm going to look at is f of 0. So I look where x is 0, and I have 2. I have 1 here, and I have 1 here. Notice this is an open circle, and this is a closed circle. So this means it is not included. This means it is included. So this is the value of the function when x is 0, not the open circle. So the y value is negative 1. You can go ahead and try this, pause it, and I'll show the answers. So the function when x is negative 1 is 1. The function when x is 0 is 3. And the function when x is 3 is 4. We can look at it as a graph, but we could also look at it as the actual defined function. So we want to evaluate the function for f of 8. So I'm going to go up here to my different domains. One of them, x is less than or equal to 0. So this is all the numbers smaller than 0. And this one is x is greater than 0, all the numbers bigger than 0. So 8 is going to fit in to this equation because 8 is bigger than 0. So I'm going to take the expression they give me, and I'm going to plug 8 in for x there. So that is 17. For b, I want to evaluate it when f of x is 0, right? X is 0. So I look here, and 0 is in both of them. So I want it when 0 is equal to it. So that's going to be my top equation because 0 is less than or equal to 0, right? 0 is not greater than 0. 0 is less than or equal to 0. So that means I'm going to plug it into x minus 2. So that's going to be 0 minus 2 or negative 2. You can try these, pause it, and I'll show the answers. right, so for 4 you should have gotten 28, for 5 you should have gotten 11, and for 6 you should have gotten 0. Notice that both of these had the -2 in them, but this is the one that had or equal to, so that is why we plugged -2 into that middle expression. So we've talked a little bit about domain. Domain is the x values, or the input of a function. The range are the y values, or the output of a function. So we're going to state the domain and range of the graph we see here. So domain or x values, we're looking, are there any x's that don't get plugged in ever? So I know that we at least plug in 0 here because I do have a solid dot on this line. And then the arrow goes forever to the left. And this arrow, even though it overlapped with that 0, goes forever to the right. So there's no restriction on my domain. So my domain is all real numbers. We write that with a fancy R, an R with 2 lines. You can write all real numbers. And some people have written it as A-R-N, all real numbers. So any of these 3 is fine. The range, we're looking at what is the output of this graph. And I notice both of my arrows go in the same direction. So no y values up here are part of my graph. So 2, 3, 4, 5, 6, none of those are part of my output. My output starts here at 1. So I know y is everything below the 1. Now I have to decide, is the 1 value included? Since this is an open circle, it's not, so it's just less than as opposed to less than or equal to. All right, another example here, domain and range again, so the arrow goes forever to the left, forever to the right, and there's nothing in between, no x values between this closed circle and this open circle. So my domain is all real numbers. My range. Now this is a very specific problem because the range is only happening at 1, right? It's never going above it here, never going below it here, so it's solidly at 1, and it's solidly at -3, right? We're not going to go above -3 here or below -3. So my range is y equals 1 and y equals -3. Just those two numbers. You could write it as a set of numbers like that. That would also be acceptable. Right? It's not an ordered pair because I have fancy brackets around it. It's not parentheses. All right, in this example, I see that my domain, again, I go forever to the left, forever to the right, so my domain is going to be all real numbers. I'm going to give you a hint. Almost every single problem we do will be all real numbers, or really every problem we do will be all real numbers for domain, but there do exist problems where it's not. My range. Since my arrows go in different directions, my range I have to pay close attention to. For the range on the right, it's everything bigger or above +4, including +4. So y is greater than or equal to +4. My range also includes the second line. And my second line is everything underneath this 3. It's not including the 3 because there's an open circle, but it's everything else under the 3. So my range is actually both of these. All right. This will not happen very often. We're usually going to have pictures that look like this if I'm asking you specifically for the domain and range. One more to look at, there doesn't have to be just 2 expressions or parts of the graph. Piecewise can have as many parts as it wants. So I'm still looking, are there any x values that don't get included? So we see that even though it's open here on the -2, it's included down here. Even though it's open here on the 4, it's included down here. So my domain is still all real numbers. My range, there's nothing happening in this picture up here. So everything's below this dot. So this dot's y value was positive 1. It's open, so it's not equal to. So its y is less than positive 1. That accounts for every single number that happens below that, which includes this line and this line. So you don't have to worry about the fact that there are 3. Everything that happens is below that positive 1. So you go ahead and give a try for these two, state the domain and range. Pause it and I'll show the answer. All right, check your answers. For number 7, the domain was all real numbers. The range was y is greater than or equal to -3. For 8, the domain was all real numbers, and the range is y is less than 0. Remember, when it's on the x-axis, y's value is 0. We're also going to write piecewise functions given a graph. So we're going to identify the different domains for each piece. So if there's 2 lines on the graph, we're going to have 2 domains. If there's 3 lines, we're going to have 3 domains. Then for each of the lines, we're going to calculate the slope, and we can do that by counting rise over run. Or we could choose 2 points that are on that line and use the slope formula. Then we're going to find the y-intercept by extending the line, if that's possible, until it crosses the y-axis. If you can't, again, choose one of the points on the line, plug that x and y and the slope you found into y equals mx plus b. So for our example, in my first picture, I have 2 pieces. So I know my function is going to have 2 pieces. One of them is going to be all the x values to the left or less than positive 1. Notice they're counting by 2's here, so halfway between them would be 1. So I'm looking at 1 where it's at x is less than positive 1, and the equation to the left is enclosed, so that gets or equal to. That means my other equation is going to be x is greater than 1. Whatever you have in the first one, you should have the same number in the second one with the opposite sign. So if this is less than or equal to, this is greater than. If this was just less than, this would be greater than or equal to. So now I'm going to come up with the equation for the graph on the left. So I can see that it passes through the point -2, 5, and it passes through the point -1, 2, which means it went down 3 and over 1. Down 3 over 1. My rise was -3. My run was positive 1. So the slope of that line is -3. So that's -3x plus b. b is where it crosses the y-axis. That's -1. So -3x minus 1 is the line on the left. The line on the right is a constant. There is no slope for the line on the right. So all I have to determine is what is the y value of this line. So I'm going down 2, 4, 5. So it's just 5 there. So any horizontal line is just going to be a single number without any x's. For b, I have 3 parts. So when I go to write my function, I'm going to have 3 parts to it. The left side, I have a solid circle, So I know I'm going to have it we're equal to, and it's less than. The first one we should have is always less than. And the x value here is negative 1. I'm going to jump to the last one. The last one should always be greater than. Again, it's a solid dot, so it's going to have the or equal to, and the x value here is 1. My middle section should take me from the negative 1 to the positive 1. So we're going to have 1 is less than x is less than, negative 1 is less than x is less than 1. I'm checking. Open or closed. This is open, no or equal to. Open or closed. This is open, no or equal to. So those are my 3 different domains, right? And that encompasses the entire all real numbers. So I already know my domain is all real numbers. I notice I didn't say that on that one, so we'll go back to that one. But now I need to come up with my actual values. So for the equation on the left, my rise is 1, my run is 1. So that's 1x. If I were to continue this line, it would cross at the positive 2. So 1x plus 2, or x plus 2, is the equation of that line. For my middle line, I count my rise and my run, and I again have 1 over 1. So it's 1x. And this one actually crosses the y-axis for me at 1, 2, 3. So plus 3. And the graph on my right, my rise over my run is again 1 over 1. So it's 1x. And if I were to continue my dotted line till it crosses it at positive 1. So this is my piecewise function for this graph. Let's talk range. I know that it will go forever underneath this positive 1. Nothing happens in the graph between, let me just get rid of this. Nothing's working. Okay. So nothing happens between this positive 1 and the 2. And then again, starting at the 2, it's going to go up forever. So my range is y is less than or equal to 1 and y is greater than or equal to 2. In this one, my domain was all real numbers, as it almost always will be. And my range, on the left, it's everything above negative 4, right, including it because that was enclosed. But then it's also going to be 5. Sorry, negative 5. It was negative 4, negative 5. So my range is both of those. It is both negative 5 and everything that's greater than or equal to negative 4. You try these last two, pause, I'll show the answers. All right, so for your answers, we have negative x minus 2 if x is less than or equal to 0, and 2x minus 3 if x is greater than 0. The domain was all real numbers. The range was y is greater than negative 3. For 10, we had negative 2x plus 2 if x is less than or equal to 1. We have x minus 3 if x is greater than 1. The domain was all real numbers, and the range was y is greater than negative 2.